Hi, everyone. Thank you for joining us for today's NF Core Bytesize talk. Today, we've got a talk by Gisela from Cubic in Germany, and she's going to tell us all about how to configure your pipelines, how to configure your resources optimally when you're running Nextflow pipelines. This is particularly targeted more at people using pipelines rather than just pipeline developers today. So without anything else, I'd like to pass over. Thank you very much.
Yeah, thank you. Thank you, Phil. I'll just share my screen. Perfect, yes. So as Phil mentioned, I'll talk today about tuning the pipeline performance, or specifically on how to specify the resource requirements for your pipelines. So the background is maybe you're a pipeline developer for a Nextflow pipeline, and maybe you'd like to incorporate your pipeline into NF Core, or maybe you're just found a nice NF Core pipeline that you'd like to use for your own data. And you're ready to launch your pipeline, potentially with high amounts of input data to your local cluster infrastructure, or even on commercial cloud infrastructure. And the nice thing about NF Core pipelines is that we have a predefined set of resource requirements that should allow you to more or less effortlessly launch these pipelines across all of these infrastructure. So what I'm going to talk today about is how do we set this up as part of the NF Core pipelines so that this is possible, and how you can also tweak a bit these defaults in case you would need to for launching the pipeline on your data. When writing a Nextflow pipeline, for each of the processes of the pipeline, there is a default, or there's the possibility of specifying resource requests. And this is, for example, the number of CPUs that this process will use, how much memory, RAM memory this process job will need, and for how long that job can run. And it's important to efficiently request those resources, and in this, because those resource requests will be passed to the cluster scheduler or to the cloud scheduler. So if you request too little resources and your job exceeds these resources, they will be killed. And if you request too many resources, on the other hand, you are using inefficiently your cluster, or when you're computing on cloud, you can have unnecessary costs. So it's important to find this balance on the resources that your processes request. And how to find the best configuration. There's not an ideal formula for that, but we'll have a look at some things that can help you find the best resource requests for your processes. So first rule of thumb would be to start small and go big. But there's another very nice tool, which is the Nextflow execution report that can help you define your resource requests. So when running an NF Core pipeline, under the pipeline results folder, there's always a subfolder called pipeline info. And under this one, you can find the Nextflow execution report. And we're going to have a look now at an example execution report for the RNA-seq pipeline. So this in this Nextflow report for the RNA-seq pipeline, in this case, the pipeline was running on AWS batch. And you can see all the processes succeeded. And an interesting section of this report is this report on the resource usage. So here you can see for each of the processes of the pipeline, how many CPUs were used in each of the processes. And you can see also statistics across all of the different samples that were running through the pipeline. So here you can see the raw usage, and there's another tab that shows you which percentage of the allocated resources were actually used. So in this case, you would like to optimize that so that you use most of the allocated resources, but also leaving a margin potentially for a bit bigger samples, or like a bit jobs that can take a bit longer than usual. Also, we have a section for memory requests. Here you can see the physical RAM that each of the processes used, and the virtual RAM as well, and what percentage of the RAM allocated was actually used by the processes. And finally, there's also a section on the job duration for each of the processes as well. Yeah, so one recommendation would be to first use some defaults that seem sensible, and then have a look at this resource usage report, and according to these values, set sensible results for your data. And how can you do that? So, when you're developing a pipeline and writing the code for it, this can be specified as part of the Nextflow configuration. So that would be part of the nextflow.config for most Nextflow pipelines. When we are talking about NFCO pipelines, we have this resource configuration in a separate file, so that's easier and cleaner to read. And that one's called base.config and can be found in the subdirectory conf of the pipeline. And this base.config is imported inside of the main nextflow.config. So inside this config file, there's the process scope, and there is where the defaults of CPUs, memory, and time requested for each of the process are defined. And you can see that in this case, the default would be 1 CPU, 6 GB of memory, and 4 hours of time, which will surely not be enough for all of the processes in the pipeline. Another thing that we can see from this default configuration is that actually we have these resources multiplied by task.attend, which means that actually whenever a process is retried, the number of the requested resources will be doubled in this case. And this we can define with these exit statements here. So we can see also, we can define also if a process should be retried or finished depending on the exit status. So in this case, for the RNA-seq pipeline, if the job ends with an exit status that is one of these codes here, that process will be retried with doubling the initial resource requests, and otherwise it will be finished. And with this max retries option, you can also define how many times this process should be, the execution for this process should be retried. So in this case, it's just one, so it will be retried once if it ends in one of these exit status codes. And in this retry, the number of requested resources will be doubled. And finally, another thing that we can see here in the default process definition is this checkmax function. And what this does is it always makes sure that the resources that you request for each of the processes will not exceed the maximum resources that you have available for computing. We'll see later how to define these maximum resources, but just to give an idea, this can be, for example, if you're launching a pipeline in your in the cluster for your institution, you will surely have a maximum amount of memory and number of CPUs that each node has. So this is to make sure that these requests don't exceed these maximum numbers. So this could be the default that is there for each of the processes, but this will of course not be enough for all of the processes of the pipeline. So there should be also higher they should be defined that it's processes that need more resources also have higher defaults there. And this can be done, or we do it as part of the NFCO pipelines with these definitions in the base.config that specify different types of processes. So for example, process low, that will need a bit higher resources than the default, but still low amount of resources, or process medium that will increase to a medium resource definition here. And this is done via labels here. And all of this code will be part also of the NF Core template. So you don't need to define this anymore, but you should just try to use those labels as they are defined in the base.config when defining your own processes. So as an example, for the FastQC process, this one contains a label already that is process medium. And this means that for this process, these resource requests here will be used. So you can define these labels for the new processes that you define as part of NF Core pipelines, and then the resource request definitions are already predefined for you. However, for some of the processes, you might need to define some defaults that are not matching any of these labels here. In this case, you can also define the resource request for that process with the with names statement, and there you provide, instead of a label, you provide the name of the process directly. In the case of DSL2, the name of the process should still be the name that is defined as part of the pipeline code here in process name, and not also including the name of the workflow or sub-workflow where this module is present. So that's how a specific request can be defined. So that in principle is taken care already for, if you're a pipeline user, that's in principle already taken care for in all the NF Core pipelines. However, sometimes you might want to change those defaults that are defined for a specific pipeline. So when using an NF Core pipeline, one of the first things that you need to define resource-wise is what are the maximum resources that you have available, being it in your local computer or in your infrastructure cluster. This can be done directly via pipeline parameters. All NF Core pipelines have the parameters max memory, max CPUs, and max time available, and you can directly specify the maximum resources there. But if you are using the NF Core pipelines very often as part with your institutional cluster, a good idea is also to define an institutional config profile as part of the NF Core configs repository. And we've had already a bite-sized talk about that. James from the Max Planck Institute in Vienna, Germany, already explained us how to make a new institutional config profile. So have a look at that talk if you're not sure on how to do that. And then the max resources would already be defined as part of this institutional profile. And what if you would like to change not only, or like define not only the maximum resources, but you would like to tweak a bit the resource request for a specific process, being it because you have especially large samples or small samples and you'd like to tweak the resource definition for that process? You can do that with a custom Nextflow config. So it's also possible to provide Nextflow configuration with this -c parameter, and note the just like one hyphen for -c because it's a core Nextflow parameter and not a pipeline parameter. And inside this custom config, you can define using the same syntax as before, special resource requests for the process that you'd like to change that. For example, in the case of the mark duplicates process here, the memory is requests changed to 20 gigabytes and the CPUs to 20. Yeah, so that's in case you're a pipeline user and you'd like to change the requests for a specific process. And yeah, if you have this very often that you need to change the defaults of a specific pipeline when running it for your data, you can also contact us on Slack so that we take care also of these defaults and tweak them so that most users don't face those problems, or even open up yourself to the base.config to change these defaults. Right, so that's all I wanted to tell you for today, and I'm happy to take any questions if there have been any things that were unclear from the talk.
Brilliant. Thanks very much. I guess that was brilliant talk. Any questions from the audience, either in Zoom or on NFCore Slack? Should check YouTube as well. Could you maybe just, I know you kind of went over it already, but could you clarify on which ways pipelines usually break for people and why they might need to do this?
I mean, one of like a way that we've seen also that pipelines break is that, for example, you're using your pipeline in your institutional cluster, and in case, for example, you're using the Slurm scheduler, you request too little resources so that the scheduler kills your job. And in the case of Slurm, it says something like error to exceeded time or exceeded memory, and in that case, it's easy to fix this problem with this custom config that I've explained in the last step, just providing, like, requesting a bit higher resources for your cluster.
Yeah, Jasmine says, could you give or show an example for an efficient and a not so efficient pipeline report? That's a tricky one.
Oh, that's a tricky one, yes. I haven't prepared a non-efficient pipeline report so far.
I guess it will look the same. It's just all those box plots will be down at kind of 5 or 10% of what you requested rather than close to 100% of what you requested. If that makes sense.
Yes, exactly. I was trying to share. Yes, exactly. So if we have a look, hope you see the report here. So if you have a look here at, let's have a look for memory, for example. I mean, even as part of the RNA-seq pipeline, there are more and less efficient processes as well, right? So here we can see, you would be looking at processes that are in the top, like close to 100% RAM allocated, but maybe not exactly at 100% to allow for a little bit of margin there. Yeah, so those could be efficient processes, for example, and those less efficient, but it can be also that just those processes don't need a lot of memory, and even requesting the minimum, they are not using it all.
It's maybe worth mentioning that generally for NF core pipelines, we try to advise that pipeline developers are a little bit generous with what they give, because we think it's better that pipelines are slightly inefficient but work most of the time versus being very efficient and breaking a lot and you having to tweak it just to get it to run. So if you always run on the same organism and the same types of samples, then it's definitely possible to streamline it a bit. Or for example, if you run on a very small model organism genome or small data sets. James pointed out in the chat that another thing that you might see if your config is not ideal for your data sets is that you might see a lot of tasks being retried. So if you're seeing the pipeline works, but you're seeing lots and lots of retries all the time, it basically it's running out of resources and having to double them. And that's another indicator that you should probably try and improve things. Right, well, thank you very much, because that was a really, really nice talk. I think we're going to be pointing back to this one a lot. If anyone has any questions, drop them into the bytesize channel on Slack now or anytime. We also have the configs channel in Slack, which is dedicated to this kind of thing. So please drop in and kind of let us know if there's anything which is unclear. And otherwise, we'll see you next week.
Yeah, see you next week then.